Alright, in this video I'm going to be solving the USACO 2019 December contest bronze. Problem 3, livestock lineup. So Farmer John has 8 dairy cows, which are named Bessie, Buttercup, Bellina, Beatrice, Bella, Blue, Betsy, and Sue. So the cows require that Farmer John milks them in an order that respects and constraints. And the constraints are where one cow must be milked beside another. So Farmer John wants to find the ordering of his cows that is alphabetically first and satisfies all these constraints. So we see in this one that Buttercup is milked beside Bella, so Buttercup is milked beside Bella, and Blue is also milked beside Bella, so Blue is milked beside Bella, and Sue is milked beside Beatrice, so Beatrice and Sue. And we can also notice that this is alphabetically first since Sue comes after Beatrice, and since Sue needs to be next to Beatrice, and Beatrice is the first name in here that is alphabetically first, Beatrice and then Sue would be the alphabetically first combination or ordering of cows that would meet all these requirements. So what do we need to do here? What we need to do is, first of all, we're going to have to, let's say we're going to solve this using brute force. So then we're going to have to know all the different combinations or types of orders that we can generate using these 8 dairy cows. So let's say it can be, if we number these cows 1 through 8, then we can have the order 1, 2, 3, 4, 5, 6, 7, 8, or we can have 1, 2, 3, 4, 5, 6, 8, 7, and so on. So once we've created all these orderings, then we should check that each of these requirements are met, as seeing that each of these cows are assigned a number, and if that number is next to it, that means the constraint is met. But if one of these requirements are wrong, it wouldn't be a valid answer. Also, we should be checking these in alphabetical order, so we should probably number them in alphabetical order first, and then when we're finding all of the different orderings that are possible, we should try to make sure that it starts from 1, 2, 3, 4, 5, 6, 7, 8. So we should use some kind of thing to sort that. And then we're also going to need to, after we're done doing all that, we'll have to convert the number of each cow back into the name of the cow. And then we're going to have to print it out. So for the permutation part, we're going to be using a type of recursive function, which is a recursive function that uses 2 strings, a left string and a right string. So in order to create all the permutations of something using a recursive function, I explained this in the last video for the CSES problem 1622, but we have to keep on adding each possible character for a letter, and then keep on creating possible strings that can be a combination of them. So let me create this first on a Google Sheet to show that. So here, let's say there are only 3 cows, and Farmer John wants to find all the possible orders of these 3 cows. Then let's say that each cow is numbered 1. Cows are numbered 1, 2, and 3. Then that means that in the left string, first of all, there's nothing, okay? Actually, in the left string, we're going to have the string. So first of all, we're going to put 1, 2, 3, which are the cows. And in the right string, it's just going to be empty for now. So in the left string, first of all, we see that 1, 2, 3 can be put in 3. There's 3 ways to sort there are three ways to choose one number from 1, 2, 3, or one cow. So you can choose cow 1, you can choose cow 2, let's put that lower, or you can choose cow 3. Now, if you choose cow 1, that means in the right, there are two and 3 cows left. So there are these cows left over. For if you choose cow 2, then there are cows 1 and 3 left over. And if you choose 3, there are cows 1 and 2 left over. Now, technically, left and right doesn't matter which is which, but in this video, we're going to just set left as the permutations or the orders we're creating. So after 1, we then have the choice of adding cow 2 or adding cow 3. So we create these 1, 2, and 1, 3. This is the same for cow 2. So after cow 2, we can have cow 1 or cow 3. So 2, 1, 2, 3. And then after cow 3, we can have cow 1, so 3, 1, or cow 2, so 3, 2. And then we keep on continuing this, but since now, for this order, we have only cow 3 left, so we just add it, 1, 2, 3. This is 1, 3, 2. This is 2, 1, 3, 2, 3, 1. 2, 1, 2, 3, 2, 1. So now we get all of the possible orderings using this method of using a left string and a right string, and then repeatedly adding these left strings, like one number from the right string to the left string. So how are we going to put this in code? Well, let me do that right now. So let's just import and import java.io. Okay, so first I'm just going to be writing the recursive function. So let's say static void var. So we're going to need a left string and a right string, right? Or recursion. And so what we're adding is right now string right. Right now the left string is going to be nothing. And the right string is going to be, let's say, it's going to be up to 8, but let's just set it to 1, 2, 3 for now. And then in the left string, we're going to have to add all exactly one character from the right string. So for I equals 0, I is less than byte.length, I plus plus. And this is for the purpose of choosing exactly one character, so one number. And then since we have that index of the right cow that we're going to send over to the left side, we change the strings now. So string, now this is let's say left 1. So left 1 is going to be left plus right dot car at I, because we're moving the cow at index I over to the left side every single time in the for loop. And then string right 1 equals right dot substring 0 up to I plus right dot substring I plus 1 to the end. And since we have these new modified strings where one cow from the right side is moved over to the left side, we can just get into the recursion part. So now we call the same function recr, and then we do left 1 and then right 1. But the thing is, every time we actually get a value and the right string becomes an empty value, and we get a specific order for the left side, we're going to have to add it to some kind of array or something. But we're going to use a set because we remember that the order has to be an alphabetical order. So if left, actually let's do it, but if right dot length equals 0, so if it's all done moving the cows to the left side, then we can do, let's say, set dot add the left side, and we'll have to create something called static tree set string and call it set. Since we're going to need to sort it alphabetically, or like 1, 2, 3, 4, 5, 6, 7, 8. And then now we can go into the coding part since we're done with the recursive function. So we'll need a scanner. Scanner in. We'll need a print writer. Print the output out. And we see that we also need, we also need an integer n, which is the lines of input. So static int n. And we'll also need some kind of, let's say, array list to sort which cows need to be next to which cow. So let's say static array list string next to. And then we're going to need, let's say, we're going to need a tree map, right? Because we're going to need to keep track of which number represents each cow, or which cow is represented by each number, because this permutation is going to be creating like, this recursive function is going to be creating like a string that contains numbers, but these numbers are not going to be the cow names themselves, but they're going to be the number that represents each cow. So we need to do static, say string character. Actually, we can set it to integer, so since it's going to be the ID, we could say. Now, and then we're going to need like the names in alphabetic order because we're probably going to need to keep track of the cows and their alphabetic order. So, and we're probably going to need to use it for cow num and to keep track of which cow, what the cow numbers are in alphabetical order. So let's just create it right now. So static string names equals new string. So the first name is, let's see. So the first name is Beatrice, I think, in alphabetical order. And then it would be Belinda. And then it would be Bella. And then Bessie. And then it would be Betsy. And then, let's see, and then Blue. And then Buttercup. And then Sue. Sue's always last alphabetically. And we're also going to need to have the string for the answer. So the order that works. So let's have answer. So we create our main. And we need to make sure it throws an IO exception. So throws IO exception. Scanner for lineup.in. And out equals new print writer lineup out. So first we have to initialize it. So public static init. And then first we have to get n, because that's the number of lines of input. So n equals next int. And then we have to set countum equals to tree map. String integer. And then for int I equals 0. So we're going to be putting each of the cows and their index inside of countum using a for loop. So countum.put names at index I, which is in alphabetical order up here. And we're also going to have to do I plus 1. Or we could just do I. Since it really doesn't matter. And then we could do next to equals new array list. And now what we're going to put in next to is going to be the first cow and the second cow, but at their specific cow ID. So they're with their numbering that we used with countum. So for int I equals 0, I is less than n, x plus. So cow1 equals countum.get in.next. And we have to set this to an integer. And then we see that for every line there are 4 unnecessary words, so must be, milked, and beside. We don't really need those words, so we're just going to do in.next 4 times. Okay. And then we're going to get the next cow, so int cow2 equals countum.get in.next. And then we're going to have to add it to the array list next to. So next to dot add cow1 plus, let's say, an empty string plus cow2, since it has to be a string. And if we don't include this part, then it's just going to be the 2 integers added together. And then set equals new tree set string. And then we're going to need to do our solve part. Void solve. But first of all, we're going to need to get all the permutations. So like use this recursive function with r. Then we're going to need a string left, which is empty, and then a string right, which is going to be 0, 1, 2, 3, 4, 5, 6, 7. And then after we call this, we're going to have the tree set up here, all full of the different possible orderings of 0 through 7, and they're going to be sorted because it's a tree set. And then for string order in set, so for the orders, we need a Boolean variable to keep track of if the order works or not. So Boolean works equals, we set it to true, and if there's any of these requirements that are not met, we have to set it to false. So for string, let's call it t next to. So if, so it has to be not. So if not order dot contains t or order dot contains together substring 1 plus together dot, so t dot substring 1 and t dot substring 0 because it's ones together. And I think there's an extra one. Let's see. Oh, and this has to be a plus, putting them together. So if either this cow is here and this cow is here, or Sue is here and Beatrice is here, that's what this section is setting. And then we're checking if that's not true. So if those two aren't together, then we have to set works to false and then break. And so if the order works, then we have to do answer because we set it up here, our answer is going to be the order, and then we're going to break it because we only want, because we only want the first alphabetical one, and since we're going through the set in alphabetical order, it's going to find that for us. And then after we found it, and since one order is always possible, and it says in here, then we can add it to a string using the cownum hash map. So string press is the result, and int I equals 0, I less than 8 plus. Then in the string order, we're gonna do res plus equals names. Since these are the names of answer.char at I minus character 0, make it into an actual character. So this minus character 0 converts any character to an actual integer. And then we have to add a new line to it, so plus new line. And then we just out.println. Actually, it has to be print because we already have a new line at the end of the string, so out.print res. And then we just do in.close. So that should probably work. Let's try submitting it. Save it. Actually, first let's try it with just system.in. So equals n let's change it to so let's try this. So it says that ANS is null. Let's see. Oh, it has to be t dot substring 0 and 1, so can't go past. Alright. And that gets the output correctly, so let's try submitting it, but this time out.println and with the correct scanner and print writer. Let's try submitting it. Java. Livestock lineup. Submit. Now, it is rather slow because you're trying to get all the possible combinations of, or the possible orders of 8 cows, which is going to be, if you do your math, it's 8 factorial, since for the first cow you have 8 possible options, the second you have 7, and so on, until it's all the way up to 1 cow left. So that's 40,320. So it takes a bit time, but it still gets all of the inputs, all the cases correctly. So I hope this video helped you or made sense, and yeah.